regression, where some of the variables, they are nominal scale variable, categorical variable, and some other are the scale variable. So I begin with an example and I start with a case of binary predictor. So this is example one. I am taking an example of a data. So let me open this hyperlinked file. Please have a look at these first two columns. One is faculty, second is research aptitude. Okay, overlook these next 1, 2, 3, 4 this columns. So let us go to the variable view and see what is this in detail. Faculty is a nominal scale variable having two values. One is science faculty, second is non-science faculty. We are investigating research aptitude of college teachers, and we have divided college teachers into two categories. One is those who belong to faculty of science, another is those who belong to faculty other than science, non-science faculty. Okay. And the dependent variable is, of course, research aptitude, which is a scale variable. Okay. So we have one nominal scale variable having two categories. Such variables may also be called binary variables because they have just two values. And now we want to conduct a regression analysis. And we want to answer the question whether, what will be the research question? Whether faculty is a significant predictor of research aptitude or not. Can we predict research aptitude of college teachers by looking at their faculty, to which faculty they belong? Okay, this is the research question posed in this particular situation. Now let us say, why cannot we do the regression analysis in the routine way in SPSS? Okay, so first of all, I'm trying that let us start with regression, as we have already learned, analyze. Okay. Okay, let us see how I have coded these. I have coded this faculty as in this manner. One is science faculty and two is non-science faculty. Okay, because we need to give numerical scores to the categories. So we have labeled science faculty. If a teacher is from science faculty, we have labeled him or her 1. If a teacher is of non-science faculty, we have labeled her 2. Okay, now come to this, we can, these are labels, science faculty. So we have 25 science faculty teachers and 25 non-science faculty teachers. So in all, there are 50 teachers. Okay, and we want to see whether we can predict research aptitude from this faculty. Okay, now let us apply regression analysis in SPSS, as we have already conducted regression analysis. So I go to regression, okay, linear, and research aptitude is our dependent variable, faculty is independent variable, and click OK. Let us see what do we get. Say, what do we get? R is 0.424, R square is 0.180, adjusted R square 0.162. Regression NOI is significant. That means faculty is a significant predictor. Constant Y-intercept is 72.8 and beta coefficient is minus 11.24. Now question here is, okay, how do we interpret this beta coefficient? These two tables are all right. This says there is a significant association between faculty and research aptitude, and this is actually inferred by this Ancova table. Here it says 18% of the variance in dependent variable, that is research aptitude, can be accounted for by the faculty, predictor faculty. And this says there is a significant relationship between these two. But now how to interpret these beta coefficient and this constant term? Beta coefficient is minus 11.24. What does it mean? If the faculty were a interval scale variable, we could have interpreted that 1 unit increase in the faculty is associated with 11.24 points decrease in the research aptitude. Okay, but the unit of measurement here is meaningless. Why? Because this is not a scale variable. Faculty is not a scale variable. So this is meaningless. 11.2, 1 unit of 1 unit increase in faculty. It does not mean anything. This is one problem. Second problem I will discuss with you is, if we let us go to the data, and if we recode this faculty in another, actually faculty is this faculty is a nominal scale variable. Okay, and we have coded this as 1 as science faculty and 2 as non-science faculty. I could have coded it as 2 as science faculty and 1 as non-science faculty. Okay, because this coding is arbitrary. We are in a nominal scale. So you are just giving one value, arbitrary value to this category, science faculty. We can have 5 as science faculty and 10 as non-science faculty. Okay. Therefore, this coding should not affect the results, but it is affecting the results. Let us see how. So results are being affected by some of the results are being affected. Some remain same by the kind of coding we are doing for the nominal scale variable. So what I'm doing, I'm recoding this variable. Okay, faculty. Here I had 1 as science, 2 as non-science, but now I reverse this. Okay, and I recode it. So the recoding can be done automatically in SPSS by using this transform option. Transform recode into different variable. We are recoding faculty. And what is the name of this? Name of the, what name will you like to give it? This should be different from faculty. Let us say it is faculty 1. Okay. And now I am defining, this is old value and new value. So when old value is 1, I replace it by 2. New value is 2. I am replacing 1 by 2 and 2 by 1. So when the old value is 1, the new value is 2. Okay, add. When the old value is 2, new value is 1. Add. So we have replaced 1 with 2 and 2 with 1. Okay. And now continue and change. So it has changed faculty into faculty, new variable faculty 1, where the values are as we have just now defined. 1 is replaced by 2, 2 is replaced by 1. Coding has been changed. Okay. So, okay. Now go to the data. In data set, we have another variable added, which is this faculty 1. This is new variable. Now you can define it just label it. 2 is science. Earlier 1 was science, now 2 is science and 1 is non-science. Okay. So what I have done basically, I wanted to see whether the coding procedure have any effect on the results. So I have changed the coding. Earlier I coded science as 1, non-science as 2, but now I have coded science as 2 and non-science as 1. And I want to see what is the effect of this on the results. Now what I do, I regress, analyze, research, regression, linear. See what I'm doing. Instead of faculty, I'm now regressing it on faculty 1. Okay. Okay. So what do we see? These two tables are same. 0.424, 0.180, 10.505, 0.002 same. Okay. But the difference is here we have plus 11.24. Earlier it was minus 11.24, now it is plus 11.24. This was the earlier table. Earlier the constant was 72.8. Now the constant is 39.8. So what does it mean? The coding should not affect our results, regression coefficients. Otherwise, there would be two kind of interpretation for the same regression coefficient. Okay. Once again, I'm just request you to notice this. I have coded this once again, recoded 2. Okay. See how, and this is recoded faculty. This is the same thing actually, recoded faculty and faculty 1. Now let us see what is recoded 2. Recoded 2 is, I have given 5 to science and 10 to non-science. Okay, I can label the category science with any number. Some usually I do it 1 and 2, but some people do it 1 and 0. Okay, so I now code science as 5 and non-science as 10. And let us see what are the results. So I once again, for the last time, regress research aptitude on recoded 2. And let us see what are the results. So again, these values are same, 0.42, 4.180. This is again same, but the coefficients are different, altogether different. 72.8 and minus 2.248. So problem with this routine kind of regression is that, okay, if you do it in a routine manner, we have different kind of coefficients, different values of coefficient if we choose to label the independent variable differently, which should not be the situation. Otherwise the interpretation will become different in all three situations. So what is the solution? The solution is the dummy coded variables. So this is the problem which I posed before you. Now I am coming to the solution. Solution is the dummy coded variable. Let us see what is dummy coded variable and how do we do it. This is problem of interpreting coefficient in a routine regression. Now coding of dummy variable. Now in this particular situation, dependent variable is research aptitude and predictor is a binary variable faculty with 1 is equal to science and 2 is equal to non-science. Okay. Now a dummy variable is a variable which has a value 1 for one category. and value 0 for the rest. Now we have variable faculty. It has two categories. One is science, another is non-science. So a dummy variable will be where science will be given value 1 and non-science will be given 0. Okay, this will be one dummy variable. Thus, two dummy variables are created here. One science coded as 1 when the faculty is of science is 1, otherwise 0. And second variable is another dummy variable known as non-science, coded as 1 if the faculty is non-science and 0 otherwise. See, what I'm doing, here you see this science 1, and I have created two variables. One I name science, another I name non-science. These are dummy variables. Okay. See, science is given value 1 when the faculty is science and 0 when the faculty is non-science. 0 when the faculty is non-science. So how I have done, I already explained: transform, recode into different variable, name the variable here science, bring it faculty here, name it science. Say science 1. Okay. And now old and new values. One was science. No, this is old value, and new value is also 1. And 2 was for non-science, and new value is 0. Okay. So what we have done, 1 remains as it is. Okay, because we are creating the variable named science, and it should be given value 1. And the other category should be given value 0. Other category was earlier 2. Now it is 0. So continue, change, and OK. So science has been changed into science 1. Okay. Okay. Go to this. So this is 111. See, this is science 1111. If you compare this column with this column, it is same. So I have shown you how to do it. Similarly, I have created this non-science. Non-science is when the faculty is non-science, we give 1. See here the faculty, from here faculty is non-science. So we have given it 1. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And if the faculty is science, okay, we have given it 0, 0, 0, 0. Because we have created a variable, dummy variable, non-science. Now, what do we do? What do we do now? This I have done. Now, out of these two dummy variables, one variable is chosen as reference variable. We will compare, okay, one variable with another variable. Out of these two, one is chosen as reference category. You are free to choose either science or non-science. Okay. The result of second dummy variable are compared with this reference category. And the regression analysis is conducted using the dummy variable I have conducted this regression and I have chosen non-science as a reference category. Okay, so I will enter only the dummy variable science into regression. Okay. Now this you have understood, I think, properly. Okay, now I have created two variables, science and non-science. Okay. Out of these two, one you choose one which will be taken as reference, and the second one will be compared with that reference. So I have in this particular case chosen non-science. I could have chosen science also, but I have chosen non-science. Okay, so I will conduct regression analysis by entering science, the dummy variable science as predictor. Let us see if we do it, what are the results and what do they mean. So what we have done now, we have created two dummy variables. Okay, as many dummy variables will be created as there are categories. In this case, there are two categories. So we have created two dummy variables. Okay, now the coding is fixed. Okay, now you cannot change this. You can't code it like 2 and 3, 5 and 10. Coding is fixed. One is where the faculty is science, 0 is otherwise, okay, for this variable. And for non-science, 1 if non-science, if you are a non-science faculty, and 0 otherwise. Now conduct the regression analysis. Analyze regression, linear, reset, and research aptitude. Okay. Now, if because I have chosen non-science category as reference, so I will enter the science faculty as predictor. And I will compare the results which we get, okay, with the non-science category. Just click OK. So you get the same table, 0.424, 0.180. Okay, here also same, and here also same. But the value of constant has changed, and value of this remains same, of course, with plus sign. Now, what does it mean? Okay, now I'm coming to that. Now we can interpret these coefficients. And if you change this reference category, then also results will not be very much different. I will show you. Okay. So what we have done, let me repeat. We have created two dummy variables because this is a binary variable. It has two categories. One variable, dummy variable, has named as science. The other has been named as non-science. And we have chosen non-science as a reference category and conducted regression by entering science as predictor. The results are like this, but before that, let us see research objective and null hypothesis. Research objective is to study the significance of faculty in predicting the research aptitude of college teachers, or even in the language which we used yesterday, to study the contribution of faculty in predicting the research. Null hypothesis is faculty is not a significant predictor of research aptitude of college teachers. The results are, you have seen the results. Results are like this. Point to see, predictor is science. Okay. Now science, why do we call it a dummy variable? Because science is not a variable actually. Variable is faculty. Science is one level of this variable. Similarly, non-science is one variable of this one value of this variable. This variable has two values, science and non-science. Okay, science in itself is not a variable, but we have to convert it into a dummy variable, which has value 1 as if science and 0 if non-science. Now, this is the regression ANOVA. F is significant because this value is less than 0.01. Therefore, this regression model is significant. Now, how to interpret these? Okay, what is this constant and what is this? Let us understand this. Actually, this 50.320 is nothing but mean of the reference category, mean research aptitude of non-science category, non-science faculty. And what is this 11.24? If you change from non-science faculty to science faculty, then science faculty is expected to achieve 11.24 more points, more marks in research aptitude scale or test in compared to as compared to the non-science faculty. So this is what is interpretation like. Say, now let us see. Table 1 gives the value of R square to be 0.18, meaning that success of the regression model in predicting the research aptitude of college teachers of their faculty is 18%. From table 2, the Ancova test value for regression is significant at 0.01 level of significance. F degree of freedom 148 is 10.505, P 0.002, which is less than alpha level of 0.01. This means the regression model is able to significantly predict the research aptitude of college teachers by their faculty. Now, table 3 gives the output of regression of each research aptitude, regression of research aptitude on faculty using dummy variable science. Now we will be interpreting, this is important, interpreting the coefficient, regression coefficient. The dummy variable non-science is not included in the model and it serves as reference for the interpretation of results of table 3. Now the value of constant is 50.32 in table 3, and this is nothing but the value of the dependent variable when independent variable is 0. That simply means that the mean score of research aptitude of non-science faculty, which is coded as 0, okay, is 50.32, because we have coded science as 1 and non-science as 0. So if you substitute independent variable as 0, the dependent variable is research aptitude. So this is nothing but the mean score of research aptitude of the faculty when the coding is 0, that is non-science. Now the contribution of faculty in predicting the research aptitude of college teachers. Now let us interpret this beta coefficient of 11.24. Okay, is significant at 0.01 level of significance. Beta is 11.24, T is 3.241, and P is 0.002, which is less than 0.01. Therefore, the null hypothesis, faculty is not a significant predictor, is rejected. The regression coefficient of 11.4, now this is important, means that research aptitude score of a science faculty is estimated to be more than a non-science faculty by 11.24. Okay, if you are a science faculty, then you are expected to score 11.24 more marks than the if you are a non-science faculty. If you are a non-science faculty, so the score of science faculty is greater than non-science faculty by 11.24, and this is significant. So this is how you interpret it. Or alternatively, the science faculty mean score of research aptitude is 11.24 points more than non-science faculty. That is, the mean score of science faculty is 50.32, ये constant है, और ये है beta plus regression coefficient, that is 61.56. Now we can compare these results with the results of the t-test. So I conclude this. What we have done, we have coded the variable faculty using dummy coded variable, and we have created two variables. One we chose as reference faculty and the other we entered as a predictor. We got the result. Now it is easy and unique. There is a unique way in interpreting the values because there are unique values. Okay. Value of beta coefficient is 11.24. Value of this is 50.32. I will show you if you change the category, if you change the reference category, then there will be a slight change, but the results are same. Now I compare these, okay? Regression and t-test comparing results. Now let us conduct a t-test. You can conduct t-test by using this chain of analyze, compare means, and independent sample t-test. Okay. Research aptitude is test variable. Faculty is, in this we are not using the dummy variable. Faculty is the grouping variable. Define groups 1 and 2. I have labeled group 1 as 1 and group 2 as 2. Science as 1 and non-science as 2. Continue and OK. Now this is the result which we get. Group statistics, research aptitude, science faculty research aptitude is 61.56. Non-science is 50.32. Okay, I have taken these tables here. Now let us look at these tables. We observe that the mean research aptitude, okay, of the science faculty is 61.56 and non-science faculty is 50.32. And B is nothing but difference of these two, 11.24. Okay. The t-test for equality of means is t value is 3.241, degree of freedom 48, significance value 0.002. So these are the same which we got here, 3.241 and 0.002. Okay, 3.241, 48.002. So actually, okay, these are actually the interpretation which we made. How did we interpret that the 50.32 was the constant and this was 11.24 was the regression coefficient for science. So this was constant and we interpreted it like this. This is nothing but mean research aptitude of non-science faculty. And regression coefficient of plus 11.24 means that the science faculty is getting 11.24 marks more than the non-science faculty. Therefore, that is why the mean of this is 50 plus 32, 50.32 plus 11.24. That is 61.56. So our interpretation of the regression, okay, which we conducted using the dummy variables tallies with this. Okay, so we get confidence if we have correctly interpreted this. Now, this is the effect of change of reference value. Okay, if you change the reference group, now what I do in regression analysis, analyze regression. Instead of entering science as predictor, I enter non-science as predictor. And that means that science faculty is a reference group. Non-science faculty results will be obtained in regression, and we will compare them with the science faculty results. So only difference is here that now constant value has changed from 50.32 to 61.56, and this has changed to minus 11.24. Okay, now let us come to this. This is effect of changing reference group. Okay. Now our predictor is non-science, not science, and science is the reference group. So this constant is nothing but the value of the dependent variable when the independent variable is 0. And independent variable is 0 when the faculty is science, because we are using the dummy variable non-science. Regression coefficient of minus 11.24 means now a faculty of non-science faculty is expected to achieve 11.24 marks less than the faculty of science teacher. Therefore, if you want to calculate mean score of faculty of science, you just add these two or subtract 11.24 from 61, it will be 50.32. So this is again matches with the results of the t-test. So this was regression analysis using dummy coded variable. Okay, and the case when there are just two groups. Now from two groups, moving on to 3 or more groups is not an issue. It is quite easy. So next, we are taking up an example. But before that, let us see how to. It can be seen from table 4 that mean score of research aptitude of non-science faculty is 50.32. It tallies with the constant term of the regression equation. Further, from table 4, it can be seen the difference in mean score of research aptitude of science and non-science is 11.24, which is nothing but the value of the regression coefficient for science faculty if non-science faculty is the reference category. And if we perform the regression analysis with the other dummy variable non-science, the value of regression coefficient will come out to be minus 11.24, and we will get the constant term as this, which is evident from table 6. The t values are same. They are identical with the corresponding values in table 3. So this is all with the case of a binary variable. Now let us take a case of multi-category predictor when there are more than 2 categories in a predictor. Okay. Now this is an example where we have 2 variables. One variable is residence, and residence has now three categories. One has been coded as urban, 2 as semi-urban, and 3 as rural. Okay. And we have general knowledge. Suppose these are students or these are children of some particular age, and we want to see whether residence affects the general knowledge. Can we predict general knowledge through residence? In one particular residence, children, they have more general knowledge than the other, and how much increase is there? Okay, this is the question which we want to answer. So, as we have already seen, okay, we have now 3 categories. Therefore, we can have now 3 dummy variables. One dummy variable we can name urban. It has value 1. Okay. Say, let me show you just one. Others will be similar because now here there are 3 categories. Transform, okay, recode into different variable. If you recode into same variable, this original will be changed. This original column will be changed into the new column, but we want to retain it as well as have another column. So therefore you do it recode into different variable. Okay. So now I want to, on residence is my input variable. I want to change residence into dummy variable. And first variable I want to create is, name is urban. So I wrote the name of the variable urban. Now it says what are the values, old and new values, because we want to recode. One coding already done exists already, and now we want to change it, the old and new values. So we coded urban as 1. In the original coding, urban as coded as 1. So which we want to retain as it is. So old value is 1, new value is also 1. Add. Now, second way, one way is old value is 2. Okay, new value is 0. Add. Old value is 3. New value is 0. Add. So we have created a variable urban, which has value 1 when the residence is urban, or and 0 otherwise. This same thing can be done. Okay, like this. 1 as 1 is all right. Okay. Now next we can do all other values. All other values 0. We have here an option, all other values. One we wanted to have written as it is, but others, whether they are 2 or 3, whatever, they have been else 0. Keep 1 as 1, else other than 1, make them 0. Okay. So continue and change and okay. This variable name duplicates an existing variable name, because we gave command that create a new variable, but it is already there. So we change this urban 1. Okay, urban 1. Now old and new values. 1 as 1, this continue. Okay. So this has created one more variable. Here. No, actually. Let me do once again. Transform. Okay. Recode into different variable. Reset. So residence. Okay. And I name it urban 1. Okay, now old and new values. Old value is 1. New value is 1. All other values 0. Continue, change, and okay. So we have now one more column, and this is 1, 1, 1, 1, 1, 1. When we are referring to urban, and all other 0. Semi-urban are 0, rural are 0. So this is how these 3 variables have been created. Okay, urban, semi-urban, and rural. Now we choose one particular category as reference category. In this situation, I have chosen urban as reference category, but you could have chosen rural as also as a reference category. I will show you if you choose rural, then what will happen. Now, first I choose urban as reference category and conduct the regression analysis. So, analyze regression and linear, general knowledge. Here, enter semi-urban and rural, leaving urban, because urban is the reference category. And just click at OK. So this is model summary, ANOVA table and coefficient table. Okay. So I have taken them here. Coding the dummy variable. The predictor residence in this case is a multi-category variable having 3 levels: urban, semi-urban, and rural. 1, 2, 3. This is the original coding. Thus, 3 coded dummy variables are created: urban, semi-urban, and rural. The dummy variable urban takes the value 1 when residence is 1 and 0 otherwise. Likewise, dummy variable semi-urban takes the value 1 when residence is 2 and 0 otherwise, and so on. The reference variable for interpretation of regression coefficient is chosen to be urban. Thus, this dummy variable is not entered, urban is not entered in the regression analysis as a predictor. The SPSS output is presented in table 7 to 9. Table 7, R square is 0.420. So 42% of the variance in this can be explained by the independent variable. NOY is significant, value is 9.773, less than 0.01. Therefore, this is a significant predictor residence. Now let us come to this. We have this constant term 49.6 and these 2 regression coefficients. One is for semi-urban, another is for rural. We are comparing these semi-urban with urban and rural with urban. Okay, as in the preceding example, we observed in the preceding example that 49.6 is nothing but the mean of general knowledge of the students or children having urban background, the reference category. This is value of the dependent variable when value of the independent variable is 0. Dummy variable. So when you have urban, reference category is urban is 1, where remaining are 0. This is the mean score of the general knowledge of urban students. Regression coefficient for semi-urban is minus 14.2. That means student from semi-urban background is expected to score 14.2 marks less than the 49.6. So if you divide 14, if you subtract 14.2 from this, you get 35.4. Okay, so this is the mean score of semi-urban. Now, similarly, a rural student is expected to have 22 marks less than that of student of urban background. So 49.6 minus 22, 6, 7, 27.6. Okay, so this is how, and the let us see there is contribution. This is significant, and this is also significant. This is value of tolerance, VIF also we can calculate. Assumptions I am not talking because they can be done on the similar pattern. Now let us see interpretation. Table 7 gives the value of R square to be 0.42, meaning that now my son is doing PhD here. Okay, he objected to the success of regression model. He says that we should not use the word success. He was listening to my presentation. Okay. Uh, by chance, he came to the room, he listened this and said, we object in our department, people object to the success of the regression model. Okay, they say that the 42% of the variance in, he is doing PhD in management in University of Minnesota, variance in the dependent variable in GK, okay, can be accounted for by the independent variable. This is what should we actually say, because it is not a causal inference. Success is used when we have cause-effect relationship. This is was his objection. Okay. Now let us move on to table 8. From table 8, the ANOVA test value for regression is significant at 0.01. This means that the null hypothesis, residence of the student is not a significant predictor of their general knowledge, is rejected. Thus, the regression model is able to significantly predict the general knowledge of student of their residence by their residence. Now coming to the regression coefficient. Table 9 gives the output of regression coefficients for predicting general knowledge by their residence using dummy variables. The dummy variable urban is not included in the model as it serves as a reference category for the independence of results of table 3 interpolation. Value of constant is 49.6 in table 9, and it is nothing but the value of estimated score of GK for the urban students when all other variables are set at 0. Rural is set at 0, semi-urban is set at 0. That is, it is the mean score of GK of the urban student, the dummy variable not included in the analysis. There is a significant difference in the estimated score of general knowledge of the semi-urban student related to an urban student, as the regression coefficient for the semi-urban variable is significant at 0.01 level of significance. So next we interpret the t-value. T-value is significant. It means that the estimated score of general knowledge of semi-urban student, okay, that the variable entered as dummy variable is significantly different from the urban student, okay, which will serve as a reference category at 0.01 level of significance. Further, the regression coefficient of minus 14.2 for the semi-urban means that estimated score of general knowledge of a semi-urban student is 14.2 point lower than that of the urban student. That means the mean score of semi-urban student is 9.6 minus 14.2, 30.54. And similarly, we can interpret. Likewise, the regression coefficient of minus 22 for rural means that the estimated score of general knowledge of a rural student is 22 points lower than that of the urban student. Thus, the mean score of general knowledge of rural student is 27.6. We next compare the results of regression analysis with one-way Ancova, and then next I will change the reference category and see what happens. Okay. So now I go to ANOVA, and as we compare the result of t-test with regression, here because there are more than 2 categories, okay, we have 3 categories. Therefore, in such situation, we use ANOVA, one-way ANOVA. It compares more than 2 categories. So let us see what are the results of one-way ANOVA. So analyze, compare means one-way ANOVA. General knowledge dependent, residence independent. Just click OK. So we have this table. ANOVA table. So value of ANOVA is 9.773 and 0.001. Let us see what is the value of ANOVA there. 9.773, okay, and 0.001. So this is same, okay. Now next is, that means, what does it mean? This means, how do we interpret it? Those of you who already know what is meant by this, what is one-way ANOVA, okay, they will be able to interpret it. This says that there is a significant difference in the mean scores of the three groups. Mean score of general knowledge of rural, urban, and semi-urban students, because this F value is significant. Okay. We have rural, we have urban, and we have semi-urban students. So the mean score, suppose its mean is mean 1, mean 2, and mean 3. These three means are equal. This is null hypothesis, and this null hypothesis is rejected. That means there is a significant difference in the mean scores of these three categories. Okay. Now, in ANOVA, we further investigated because the F value is significant. Now, we have to identify which groups differ in their mean score. Suppose there are three pairs, mean 1 and mean 2, mean 1 and mean 3, and mean 2 and mean 3. So rural, urban, rural, semi-urban, and urban, semi-urban. So out of these three pairs, which one are significant and which ones are not significant? So in ANOVA, this is done like this. Further, we have to investigate. This is known as post hoc test or follow-up test. Analyze, compare means one-way ANOVA. Because this is significant, we go to post hoc test, and we use test from there. I am choosing Tuckey's test. Why? I cannot answer here because the long discussion. So, okay. So I get a table like this. There are two kinds of table. One is this, and the other is this. Okay, I have chosen this one. They are almost identical in making a decision about. I have copied and pasted this one. So this table gives you the results of post hoc test. Post hoc test means pairwise comparison. ANOVA is a general test. Okay, it tells you whether the groups differ or not. So if the groups do not differ, then finish. We need not go further. But if the groups differ, then we need to go further to find out which pairs are different, significantly different from each other in respect of their mean scores. So this is one kind of output of such result. We have rural, semi-urban, and urban, and these are the mean scores: 27.6, 35.4, and 49.6. So first thing you can observe that these mean scores tally with the mean scores which we got in our regression analysis. Mean score of semi-urban, the constant was 49.6 because urban was the category which was chosen as reference category, and the mean scores of semi-urban was 12, 49.6 minus 27, this much less than, and if you subtract it, this was this much less than semi-urban. So these values tally with this. Okay. Now how to interpret this particular table? There is a difference, significant difference between rural and urban. rural urban is significant, and semi-urban urban is significant. But rural urban is not significant. Say our results were these two, semi-urban, urban, rural urban, and semi-urban urban. This result we did not get. Why? Because we chosen 49.6 as a reference category, and we got two beta coefficients, one for rural, another for semi-urban. And both of these beta coefficients were significant. Therefore, there was a significant difference in these two mean scores, okay, in these two pairs. But we did not get any information regarding this. So the results of this tallies with this. But if you want to compare between rural and semi-urban also, then you can change the category. Okay, so let me now do this exercise and change the category. So what do I do? Analyze, regress, linear. And now I am changing the category, and I'm entering urban here. Now rural I did not enter, rural. Okay, therefore rural is the reference category. So now rural can be compared with urban. Rural can be compared with semi-urban. Okay. Okay. So we get this 27.6, 7.8, 22. This is the table which we get 27.6, 7.8, 22. Okay. See, now our reference category is rural. So this is mean GK of rural students. Okay. Now this is 7.8 regression coefficient, and it is plus. Therefore, it is semi-urban student is expected to have 7.8 more marks than this. If you add to this 14, 15, 35.4 will be the mean score of semi-urban. And urban student is expected to have 22 scores more. So add this to 20, we have 49.6. But now, if you compare urban with semi-urban, we find that t value is 1.546 and the significance value is 0.134. It is greater than 0.05, therefore not significant. So this result also tallies with the result of the post-hoc test in Ancova. Here what do we find? Actually, this is pairwise homogeneous subset. This is homogeneous subset. These two are homogeneous, means they have no significant difference in their mean scores. And because homogeneous, there are two homogeneous subset, one where there are two means they don't have any significant difference, but this is different. So if one of the group is here, another is here, then there is a significant difference. One is here, another is here, there is a significant difference. But if both are in one column, there is no significant difference. So these results also tally with the results of the Ancova. So actually, regression analysis can be used to conduct independent t-test, and Ancova, you will get the similar results, identical results. So finally, let me move on to a situation when we have mixed predictors. That means one of the predictor is categorical and another is scale variable. So let us come to this situation. Example. Now, please have a look at this data. We have post scores, say post achievement score, pre scores, pre achievement scores, and treatment. Okay, this is treatment. So treatment has two values, one as module and two as e-lecture. And post score is scale variable, pre score is scale variable. This is pre-test post-test situation. Two groups, pre-test post-test, yeah, equivalent control group design. Both the groups have been pre-tested and both the groups have been post-tested, and one group is given treatment 1, that is module. Second group is given treatment 2, that is e-lecture. Now let us see, we want to regress the post-test scores on treatment as well as pre-test. So for this, because treatment is categorical variable, so we create dummy variables. One variable is this treatment module. Okay, because other variable is treatment e-lecture. Okay, even if I don't create it because I'm not including it, that is my reference category. So I can create just one. Out of two categories, I'm creating just one. Okay, because the other one I do not enter in the pretest. So I hope you get it. Treatment has two variables. So I could have created treatment module and treatment e-lecture. Okay, but I created just treatment module. Okay, because treatment e-lecture is not used by me in in entering in regression analysis as a predictor. And I don't want now to show you if I change this, then what will happen, that has already been considered. So I have just created one treatment module. Okay, and treatment module is one when this is module, treatment is module, and otherwise 0. So I have recoded it. Original recoding is 1 and 2. I have coded it now, recoded it as 1 and 0, dummy variable. Okay. Now we go to regress. Analyze, regress. Because this involved one categorical variable, so therefore I had to create dummy variable. So post is our dependent variable. Treatment module is our dummy coded variable, and pre is our another interval scale variable. It can be entered as such. We did not create dummy variable. Okay, okay. So this is what we get. So we have model summary, R square, adjusted R square, regression Ancova, which is significant. Okay. And this treatment module regression for this dummy variable is 14.336, pre 0.443. Okay. Now how to interpret it? Now interpretation is clear. We are comparing the regression coefficient is 14.336. Okay. This means that the module group, they are expected to achieve 14.336 marks more than 31.058, which is the mean score of the dependent variable of the reference group. But here is problem, because this pre-score does not have 0. All other the cases which we discussed till now had 0 as value of the variable, but this does not have a 0 as a value of the variable. Okay. Say what I am saying is This is the, now constant is the value of the dependent variable when predictors are 0. Okay. Treatment module has 0 as value. 1 and 0. If it is module, it is 1. If we lecture, it is 0. So 0 value is there. But in pre-test, there is no 0 value. So we cannot interpret this constant properly. For this, we need to have something else, and that is we will center this pre at the mean, and this can be done like this. Say this is the data. Okay. Now for pre-scores, okay, I will calculate the mean of this first of all, mean score. So going to descriptives, pre, find its mean. Options, you just select mean. I want its mean. Okay. So mean of this is 15.8571. Okay. Now from each score, I subtract this. I copy it, edit, copy. Go back to data. Now create another variable, transform, compute. And the name of the other variable is centered pre-scores. Centered pre, centered at mean. Okay. Centered pre at mean. And the formula is pre minus mean minus control V. So what I have done, I have created another variable. Okay. And this variable is nothing but deviations of the pre-scores, okay, from mean. Okay. So I have got another column here. And towards the end, this is centered mean. Earlier I had this pre-centered, the same thing, same thing. So I'm deleting it. I showed how to do it. Now you regress, analyze, regression, and you do the same thing. But instead of taking pre, you take pre-centered. Okay. And okay. Now see, all other things remain same, but the constant has changed. Constant has become 38.08 to y-intercept has changed. Let me come to this. Here earlier it was 31.058. Now when we entered pre, 0.443, and this was regression coefficient, and 2.190, 0.038, 0.437. With centered, now making the constant interpretable, with this pre-centered, when we regressed pre-centered, this has changed, but all other things are same. 0.038, 14.336, 0.443, 0.437, all other things remain unchanged. This constant has changed. Why? Because the value of the constant is value of the dependent variable when predictors are 0. There was no problem with treatment module predictor. This has 0 when we have the treatment as e-lecture. But pre-knowledge was not having a 0 as value. Therefore, we did like this. Now, table 12 shows the value of regression coefficient for the dummy variable module is significant at a 0.05 level of significance. Okay, this one we are now. T is 2.190. I have left the model summary and all, that is repetition. T value is this much and significance is this much. So T value is 2.19, significance is 0.038, which is less than 0.05. This means that the estimated achievement score of a student treated with the module is significantly greater than that of a student treated with the lecture approach by 14.336 point, controlling for pre-achievement. When pre-achievement is held constant. The value of constant, however, cannot be meaningfully interpreted as pre-achievement does not have a 0. Thus, we cannot say that 31.058 is the mean score of e-lecture group by controlling for pre-achievement. To be able to say this, we shall have to center the pre-achievement at its mean. This can be done with the help of SPSS. The resulting value of 38.082 is the mean score of e-lecture group controlling for achievement. Now we have interpreted this. Okay, these are nothing but mean score of, this is nothing but mean score of e-lecture group. Okay, controlling for the pre-scores, and this is nothing but add to it 14.336, 38.082 and 14.336, 814 to 52.418. This is nothing but the mean score of module group. Okay, mean score of module group. Adjusted mean score for the module group, or mean score for the module group controlling for pre-scores. Now this can be easily checked with Ancova. Okay, although we have not studied analysis of covariance, but let me show you. We can discuss in detail in the coming 2 sessions. So how do we perform Ancova? Analyze, compare means general linear model, univariate, post is dependent, pre is a control variable, covariate, and treatment is a fixed factor. Okay, this is estimated marginal mean or adjusted mean or means control for the covariate. So display mean for treatment. Okay, continue and okay. So I get these 2 tables, test of between subject effect, and this is estimated marginal mean or adjusted mean or means controlling for pre-score. So as you can see, 52.418 and 38.082. So go back to this. This is Ancova results with the same data. In Ancova, we will learn, we interpret these 2 pre, even this pre is not interpreted, but you can see it here, pre 0.625, 0.437. So this value tallies with this 0.437. Okay. Now here it is F and there it is T. So this value is different. ये For treatment, it is 0.038. Okay, 0.038. Here it is f. F is the square of t. And if you see the adjusted treatment wise adjusted mean score means mean scores for the two groups controlling for pre-scores covariate. So these means are 52.418 and 38.082, the same values which we received, which we obtained through regression analysis. This was constant and this is regression coefficient. If you add it, it will become the mean of this group, treatment module group. And this is mean of treatment lecture. So this is all for today. What we did regression using categorical variables. First, which have two categories, then which have more than two categories, and lastly, case when we had mixed factors. So this was all for today. Let me go through the chat and see if there is any question. Oh, today's chat is totally empty. No observation, no question. Actually, most of the participants joined little late. Any question live is welcome. Hello? Listening? So, let me conclude. Okay. Now I got at least one or two listening. Okay. So, because I did not find anything in the chat, so I was worried whether I was live or not. Okay. So thank you all for giving your valuable time, and we meet on 2nd and 3rd. Okay, 2 days are break for celebration of New Year. We will meet on 2nd and 3rd. Thank you all. Happy New Year to you also. Happy New Year to all. Thanks. Thank you all. Happy New Year once again.